So the next set of functions that we are going to study are exponential functions and logarithmic functions. So what is an exponential function? A function of the form y is equal to a power x, where a is a positive real number, is called an exponential function. And we don't take a is equal to 0, because if a is equal to 0, a power x will always be equal to 0, and when x is equal to 0, 0 power 0 is not defined. So there is no exponentiality in it. And we don't take a is equal to 1, because if you take 1 power x, this will always be equal to 1. This will be a constant function. So we don't take these two values. So we limit our a to positive real numbers, which are not equal to 0 and 1. So a greater than 0 and a not equal to 1, then y is equal to a power x is called an exponential function. So we also don't take negative numbers. A is not equal to negative numbers, because if you take negative numbers for some powers of x, the values will be complex. For all the values of x, the values will not be real. For example, if a is equal to minus 1, so minus 1 power half becomes root of minus 1, which is not a real number. So for many values of x, the answers will not be real numbers. So this will not be nicely defined in all real numbers if the base is a negative number. So we don't take negative bases. We don't take base 0, we don't take base 1. So our base, if you see, our base can be any positive number, but not equal to 0 and not equal to 1 and up to infinity. That is between 0 to 1 or 1 to infinity. For example, y is equal to 2 power x is an exponential function. Y is equal to 3 power x is an exponential function. So y is equal to minus 3 whole power x is not an exponential function. This is not a function in real numbers. So 2 power x, 3 power x, or you can also have fractions. So between 0 to 1, that is 1 by 2 whole power x, 1 by 5 whole power x, so on. So all these are examples of exponential functions. And once you take an exponential function, so the domain of an exponential function is all real numbers, because 2 power x is defined for positive numbers as well as negative numbers. For example, if you take 2 power x, so if x is equal to 0, you get 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, so on. As x increases, the value of 2 power x increases. And x can be negative numbers also. 2 power minus 1 is 1 by 2, 1 by 4, so on. So here x can take any real number. So the domain of this function is real numbers, and the range is nothing but positive real numbers. If you raise 2 to any power, either positive power or negative power, you are always getting positive numbers. So the range is r plus r open 0 comma infinity. So you won't get 0. So open 0 to infinity is the range of this function. So let us try to draw the sample graph of this function. So let us take, for example, y is equal to 2 power x. So if you have to draw the graph of this function, so let us take a table of some sample x and y values. So when x is equal to 0, y is equal to 2 power 0, which is equal to 1. When x is equal to 1, y is 2 power 1, 2. When x is equal to 2, y is 2 square, which is 4. When x is equal to 3, y is 2 cube, which is equal to 8. And this goes on. As you can very clearly see, as x is increasing, the value of y is also increasing. And if you go to negative values, when x is equal to minus 1, the value of y is 2 power minus 1, 1 by 2. So when x is equal to minus 2, the value of y is 2 power minus 2 is equal to 1 by 4. And this also goes on. As x goes to minus 3, it is 1 by 8, minus 4, 1 by 16, so on. So if you plot all these values on the graph, so the first point is 0, 1. That is when x is equal to 0, y is 1. So 0, 1. When x is equal to 1, y is equal to 2. So you have this point. When x is equal to 2, y is equal to 4. So the point has gone quite upwards. And when x is equal to minus 1, the value of y is half. And when x is equal to minus 2, the value of y is 1 by 4. That is 0.5, 0.25. So these are some sample points on this graph. So now if you join all these points, the graph looks something like this. So as you go more and more towards minus infinity, this curve tends to touch x-axis but never touches it. This curve goes closer and closer to x-axis. So this is the sample curve for y is equal to 2 power x. And this is a general shape of the exponential function. So if you take y is equal to 3 power x, also it looks like this. But there will be a slight change in the values of the function. When x is equal to 0, 3 power x also is going to 1. But when x is equal to 1, it goes to 3. So if you have 3 power x, it grows still faster. It grows still faster. So all the graphs of exponential functions, if the exponent is greater than 1, are going like this. So all these are increasing functions. That is, if x increases, y also increases. But this is not always the case. So if you take y is equal to 1 by 2 whole power x, that is if the base is in between 0 and 1, if the base is a fraction, the values of x and y looks reverse if you see. So x and y. So if x is equal to 0, y is equal to 1. When x is equal to 1, y is half power 1 is half. When x is equal to 2, it is 1 by 4. When x is equal to 3, it is 1 by 8. Now when x is equal to minus 1, 1 by 2 whole power minus 1 is 2 power 1. It is 2. Minus 2 is 4. That is, if x is increasing, the value of y is decreasing. When x is decreasing, the value of y is increasing. And if you draw the graph of this, the graph goes like this. So if x is 1, y is half. If x is equal to 2, y is 1 by 4. And it goes on like this. That is, if x is increasing, y is decreasing. So if the base is in between 0 to 1, the exponential graph is a decreasing graph. That is, this function is decreasing. And when the base is greater than 1, the function is increasing. So you can have both the graphs depending on the value of the base. But the domain is always equal to real numbers and the range is always equal to open 0, infinity. All the values above x-axis are being covered. Open 0 to all infinity. So this is a definition. Increasing, decreasing nature needs to be remembered. Domain and range needs to be remembered. And the values of the base, that the base is always greater than 0 and not equal to 1 for exponential function. So the next function that we need to understand is the logarithmic function. It is nothing but y is equal to log x to the base a. And you know that for logarithmic function to be defined, the base a has to be positive and not equal to 1. So if a is a positive number and not equal to 1, this function y is equal to log x to the base a is called a logarithmic function. And logarithmic function is defined only for positive real numbers. So inside log function, you cannot have a negative number. Log of negative numbers is not defined. So the domain of logarithmic function is open 0 to infinity, and the range of logarithmic function is minus infinity to infinity. So the values of logarithmic function extend from minus infinity to infinity. So how does the graph of logarithmic function look like? So let us draw a sample table of x and y. So let this be x and let this be y. So we know that log 1 to any base is equal to 0. So let us take a sample function. So y is equal to log x to the base 10. So if x is equal to 0, log is not defined. Log is defined only for 0 to infinity, open 0 to infinity. So what is log 1 to the base 10 is equal to 0. Log is nothing but the power of 10 present in x. So log 1 to the base 10 is equal to 0. So what is log 10 to the base 10? Log 10 to the base 10 is 1. Log 100 to the base 10, if x is equal to 100, log value is equal to 2. Similarly, if you have 10 cube, log 10 cube to the base 10 is 3, so on. So if x is equal to 1, y is equal to 0, and as x increases, log increases very slowly. So at x is equal to 10, it becomes 1, at 100 it becomes 2, at 1000 it becomes 3. That is, from here log increases, the increase in log becomes a very flat function. So you need to have a lot of increase in x for a relative increase in y. So if y has to increase by 1 unit, x has to increase by 90 units. Next, x has to increase by 900 units. Is the graph is becoming flatter. And what is log 10 power minus 1 to the base 10 is nothing but minus 1. That is, if you have 0.1, the value becomes minus 1. That is, the value of log becomes negative, and this negative number goes on till minus infinity. Log 10 power minus 5 is nothing but minus 5. So as we go to higher and higher negative powers, the number becomes closer and closer to 0. So 0 is nothing but 10 power minus infinity. So 10 power minus infinity to the base 10 becomes minus infinity. That is, at very very close to 0, value becomes minus infinity. So this is how the graph of log x to the base 10 looks like. So as long as the base is greater than 1, the graph is an increasing graph. So if the base is greater than 1, the graph is an increasing graph. Similarly, if the base is between 0 and 1, if you draw the graph of log x to the base 0.5 or so, or 0.1 or so. So if the base is in between 0 and 1, you get a decreasing curve. So the curve looks something like this. So this is if 0 less than a less than 1, and this is if a is greater than 1. So you have two possible curves for logarithmic function, and the domain of the logarithmic function is open 0 to infinity, and the range of logarithmic function is minus infinity to plus infinity, and this is the graph of the function.